Hello students, welcome back. Let's do another problem from 5.4. We're talking about Laplace transformations here, so I guess this is rather important. We did problem number 8, which is kind of similar to problems 5, 7, and 9. And we want to do another problem which is kind of in line with 11 or 13. Which one shall I select? Let's go to problem 14, the last problem in that page, and let me get the problem. T y double prime plus 2y prime plus 9ty prime is equal to 0. And let's solve this differential equation. And this is strange. This cannot be right. I'm pretty sure this is a mistake. I think this is just y. Well, let's follow through first. What if I'm wrong? I'll do this. Because you see, this looks like second order equation, but actually it's first order. If you take z as y prime, then y double prime is just z prime. So we get t times z prime of t plus 2z of t plus 9t times z of t is equal to 0 is my differential equation, or t z prime of t. Well, let's put these two together. Okay, see, these two together, and then we ended up with a linear equation like this. And this is first degree, first order. And how do we do that? Well, make it into standard form, plus divide by t, 2 over t, and plus 9t over t, so 9, and z of t is equal to 0. Yeah, it's this equation here. Let's put a little bit more space so that I can read better. And then this is p, and that's f, so we can find out the integrating factor. Integrating factor is exponential of the integral, or the antiderivative, of p of x, p of t, excuse me. In this case, what is p? It's this one. So antiderivative of that, let me expand the font a little bit. Antiderivative of that is antiderivative of 2 over t so this is 2 log of t plus antiderivative of 9 is 9t, so we get this expression. And then we can easily work it out. E to the 2 log of t times e to the 9t like this. And we can simplify this logarithm using log rule. E to the log of t squared times e to the 9t, and what is this? Log and exponential cancel each other out. I get just t squared times exponential of 9t, and that is the integrating factor. So once you have this integrating factor, multiply this, and I'm gonna get this equation here. The derivative of this integrating factor, t squared e to the 9t times z of t is equal to this integrating factor times the right hand side, which is 0. So we have 0. So we have this equation here, and I don't need this large, so let me go back to the smaller font, and we can find out the inside by taking the antiderivative. What is the antiderivative of this 0? Any constant will do. Let's say C1. Oops. I have to rewrite. I lost my math mode. T squared e to the 9t times z of t is 0. Therefore, t squared times e to the 9t times z of t is equal to C1 and arbitrary constant, but I named it as C1 because I have to take the antiderivative again because this is actually y prime. So I'm going to need C2. Z2 is C1 times t to the negative second power e to the negative 9t power. It looks like this. And this one is, as a matter of fact, y prime because that was a setup. So what do I get? Y prime of t is that, this thing. So y of t is nothing more than the antiderivative of this. T to the negative second power e to the negative 9t power. And then what is this? We have this function plus, I'm going to get arbitrary constant, integral constant. We're going to need two integral constants here. First integral, first integral here that gave me the C1, and then the second integral gave me the C2. And that's pretty much expected because this is actually a second order equation, even though it can be reduced to the first order. And if you look at it as a linear combination, you can regard that times 1 is hidden, so we have this antiderivative function as one solution and constant 1 as another solution, which are linearly independent of each other, and linear combination will give you the general solution. So this is correct answer. I'm pretty sure this is. Let's check. T times second derivative plus 2 y prime of t plus 9t times y prime of t equal to 0, and so for y of t and okay, and this expression is this integral because it could not be calculated in traditional means. Mathematica created this expression times C1 plus C2. Yes, what I have here is correct, which means now I'm certain that this problem is not what the textbook author intended.